For today, we're just going to do one more example of a type of problem that you could solve using the rules from section 10.2. In this problem, we are talking about the Earth, which is a sphere, obviously. So what we're told is the radius of the Earth is about 6,400 kilometers. That's an approximation, and it varies depending on where on the surface of the Earth you're going to, because the Earth is not totally spherical. But we're going to use 6,400 kilometers as the radius. The latitude of Columbus, Ohio is 40 degrees north. We're going to sketch the Earth and a circle of latitude through the city. So to sketch the Earth, let's make a circle. And to try to make this look a little three-dimensional, the Earth has an equator, which looks like this. Here's the center of the Earth. And what we're talking about is Columbus, Ohio, which is at 40 degrees north. So that 40 degree north latitude means that this circle, this arc here, is 40 degrees. In other words, if we draw from the center of the Earth out to the equator, and from the center of the Earth out to a point on the surface along that line of latitude, that central angle is 40 degrees. So here, what we want to do is find the radius of this circle. The radius of this circle goes from the center of the circle out to the edge of the sphere. We need to find this length. That's r. We know that the radius of the Earth is 6,400 kilometers, which we could write here. But remember that every length from the center of the sphere to the surface will be the same, just like every radius from the center of a circle to the edge is the same. So here, this is also 6,400 kilometers long here. And what we're going to do is we're going to connect this point at the center of the sphere up to the center of the circle. This has to be perpendicular because of the way that lines of latitude goes. They are always cut parallel to the equator. So here, what we have is a right triangle where one side is r and the hypotenuse is 6,400. We also know one of the angles. The 40 degrees is the central angle here, which means that inside of this triangle, I have an angle of 50 degrees. We have a right triangle where one leg is r, the hypotenuse is 6,400, and one of the angles is 50 degrees. What do we do when we have a right triangle and we know one of the angles and want to find a side? We use trigonometry. So here we have the 50 degrees. R is the opposite leg. 6,400 is the hypotenuse. So we know sine equals opposite over hypotenuse. The sine of 50 degrees equals r over 6,400. I'm going to multiply both sides by 6,400. And then I'm going to go to my calculator and find an approximation of 6,400 times sine of 50. 6,400 times sine. Actually, let me check and make sure I'm in degree mode. 6,400 times sine of 50 is around 4,902.68. So we'll go to the nearest kilometer since all these numbers are rounded. Around 4,903